Hey guys, I wanted to walk you through another limit problem where you're supposed to find delta for a given epsilon of a problem. And I'm going to walk you through problem number 42 in your textbook if you kind of want to follow along. And then tonight I want you to do problems 39 and 41 on your own. Check your work in the back of the book to make sure that you're understanding it. But when we're talking about the definition, you should have watched the two videos about the definition of the delta epsilon definition of limit and how that really applies and what it's really saying in layman's terms. And we're going to use that definition to find delta for a given epsilon. In this case, in a problem, if you're finding delta, you'll be given epsilon. And here's my problem in 42. I'm supposed to use this limit as x approaches 5 of x squared plus 4, and it's equal to 29. So I'm going to go ahead and start labeling things just so I know what I'm looking at. This is my c value from my definition. This is my f of x. And this is my limit, or L. So when I refer to this notation that the limit as x approaches c, f of x equals L, that's what I'm looking at. Now there's another part that tells me that from my definition that if I pick any epsilon greater than 0, for any epsilon greater than 0, that's just an interval around my actual limit. So the difference between my function and that limit is going to be less than epsilon, and moreover, I'm going to be able to find a value x minus c that's less than delta. So it just means for every interval around my limit, I'm also going to find an interval around c that's going to work. I'm going to go ahead and flip-flop this back to our problem here. I'm given an epsilon in problem 42 that epsilon is equal to 0.01. So they actually say find epsilon for my function x squared plus 4 minus my limit, which is 29, less than 0.01. So just to continue with this same pattern of labeling, this is my epsilon here. And this is my f of x. This is my limit. So you can see this looks just like the definition. Now moving forward a little further here, what my goal is, and something that I would suggest that you do, is just at the end of every problem that you write down what your goal is. So my goal is to get x minus c less than delta. Well, my c coming back here was 5. So I want x minus 5 to be less than some number delta. And this is what I want to find. So how am I going to find that? Well, let's go back to my initial equation here. And I'm going to go ahead and erase this out so I can do a little work. I want to manipulate this to get to that goal of x minus 5 being less than some number delta. So the first thing I'm going to do is simplify this guy. So this is x squared minus 25, which is less than 0.01. That stays the same. Well, this is nice and neat. I actually can factor this out to x minus 5 times x plus 5 less than 0.01. And this is also good because I see my goal in sight right here. Okay, do you see that this is matching my goal? So I'm almost there. So I'm going to leave this x minus 5 by itself, and I'm going to move my 0.01 over the absolute value of x plus 5. Okay, now this is where the conceptual part is going to come in a little bit here. When I look back at my original function, or my original limit definition, I see that c equals 5. Now, I'm looking at, by my definition, an open interval including c or around C, but it may not be including C. So if we're going to go verbatim. So I'm going to say that X is going to be somewhere between 4 and 6, okay? Which makes sense. 5 is between 4 and 6, so that's totally fair to pick that. So I'm going to assume that X is between 4 and 6. In order to get a smaller delta, because my goal is to look really, really close to my C value, my X equaling C, so I'm going to pick this. And this is where I told you, you can pick your delta just as it exists. So I'm going to find something really, really close. I'm going to pick X equal to 6 here. So in this case, X minus 5, that stays the same. It's going to be less than 0.01 over. Now I'm going to add my 6 plus 5, which is 11. Okay, move this down a little bit. And now all I'm going to do is just show that I can multiply this out. And now I have X minus 5 is less than 0.01 divided by 11 is 0.0009. And what have I just found? I have found a delta that works with my definition. So you can see, if I pick 4 and plug that in and gotten 0.01 over 9, that would still give me a delta. And guess what? That delta would still work. If I had that as my delta, I could still find an answer to my function, but I just chose to get a little bit closer, okay? And so this is my delta, and moreover, it's derived from my original information that was given to me. And that's really the key here, guys, is that you don't just pick a delta willy-nilly if you're asked to find delta given an epsilon. You actually have to derive that delta from something. But there will get a point where you will be able to choose a little bit. And so this is just kind of showing you how that process can go. All right. Hopefully that answers a few of your questions and clarifies a couple things. Please try numbers 41 and 39 on your own. 41 is very similar to this, where you would factor out, and 39 is more like the problem in the book. So make sure you read over the lesson as well, and see you in class tomorrow.